collaboration with IQAC of college. Welcoming the guest is our Asian tradition and also an inseparable part of any event. Now I call upon Srimati Rohina's Faculty of Chemistry to welcome all the guests and the participants of today's webinar.
Good morning to all. Atiti Devo Bhava. We belongs to the nation which strongly believes that guests are gods. Welcoming guest is our culture. First, I render my heartfelt welcome to our distinguished chairperson of the college governing body, Srimati K. Girija ma'am, who has supported our department by all means in holding this webinar. A warm welcome to you, madam. I extend my heartfelt welcome to our chief patron and our beloved principal, Dr. S.Y. Timmareddy, the man behind this event. Heartily welcome to you, sir. I express my heartfelt welcome to our today's resource person, Professor K.S. Lokesh, who have joyfully consented to share their knowledge in this webinar as resource person. A warm welcome to you, sir. It's a great joy for me to welcome all the participants comprised of teachers and learners from across the nation who are the true bright color and vigor to this event. Lastly, I welcome all those who have contributed their efforts in organizing this event. I welcome one and all. Thank you.
Thank you, ma'am. Thank you, ma'am, for welcoming the guest. I humbly request our esteemed chairperson of a college governing body, Srimati K. Girija, madam, to ignite the gathering with her inspiring address.
Good morning to all. Veerashaiva Vidyavartaka Sangha Ballari was established in 1916 at Ballari with a view to provide education to all strata of society in and around Ballari district with a focus to rural students. This crusade against illiteracy and ignorance has continued to create not only a literate society but also a knowledge-based one. The Veerashaiva Vidyavartaka Sangha thus runs 41 educational institutions with hostels and philanthropic organizations in Ballari, Koppal, and Davangere districts, covering pre-primary, primary, high school, pre-university, diploma, undergraduate, and postgraduate courses. These courses encompass arts, science, commerce, management, pharmacy, education, and law. It aims at carrying on the good work in the years to come. I feel immensely happy for the joint venture by physics and chemistry departments, which have jointly organized a national webinar on nanotechnology for sustainable development. I am very confident this constructive event will benefit all the participants at the best. I hope the departments will conduct more and more such events in order to update the students with latest trends of knowledge. I feel it is right time to wish the team all the best and hope the webinar will be a grand success. Thank you.
Thank you, madam. This webinar is a fruit of motivation by our Honorable Principal, Dr. S.Y. Timmareddy, and without his support and encouragement, this event would not have been held. It is the time for our Principal, Dr. Y.S. Timmareddy, to deliver the keynote. Please, sir.
Good morning to all. Esteemed chairperson of our college governing council, Srimati Girija madam, organizing secretaries, Professor H. Shambhavi and Dr. Allum madam, resource person, Professor Lokesh sir, conveners, co-conveners, teaching faculties, IQAC coordinator, participants, welcome you all to this one-day national webinar on nanotechnology for sustainable development. I'm very happy to address the participants in this occasion. First of all, I would like to give clear-cut information about my college. Srimati Allum Sumangalamma Memorial College for Women is the lone premier women college of VV Sangha. It has continued to fulfill the aspirations of girl students of the region. It has played a pivotal role in shaping the career of n number of students This college has created an educational ambience to all the girl students of not only Ballari and neighboring districts of Karnataka, but also for students of neighboring states of Andhra Pradesh. This college was established in the year of 1969 with a strength of 164 students, and presently it can boast of 1,484 students. It is a full-fledged college with undergraduate courses in arts, science, commerce, management, computer applications, and post-graduations in MCOM. Its goodwill stands on the consistent securing of good results and ranks. So consequently, it has become synonymous with academic excellence. It has research-oriented and highly qualified, competent teachers with doctoral degrees. Degree course in major and minor chemistry was started in the year of 1969 with an initial strength of about 20 students. Today, the department records the strength of 620 students. And 10 years later, that is in 1979, the Department of Physics was started. Till date, both the departments are working at their best for the holistic progress of the students. So, here nanotechnology is the branch of technology that deals with dimensions and tolerance of less than 100 nanometers, especially especially so manipulations of individual atoms and molecules. It is a science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanotechnology is the design, production, and application of structures, devices, and systems of manipulations of size. Nanotechnology can be classified into different types. So according to size, morphology, so physical and chemical properties. Some of them are carbon-based nanoparticles, ceramic nanoparticles, metal nanoparticles, semiconductor nanoparticles, so polymer nanoparticles, and lipid-based nanoparticles. Nanotechnology is small solutions to big problems. So invisible particles that fight cancer cells, further microprocessors that consume less energy, nanotechnology used in agriculture, industry, medicinal, and energy uses. Nanotechnology materials can effectively be made stronger, lighter, more durable, more reactive, faster kind of computers and power resources. So, in order to achieving economic developments, we need the applications of the nanotechnology. Sustainable development that meets of present without compromising the ability of future generations to meet their own needs. Sustainable development has continued to evolve as that protecting the world's resources while its true agenda is to control the world's resources. Environmentally, sustainable development growth refers to economic development that meets the needs of all without leaving future generations with fewer natural resources than those we enjoy today. The essence of this form of development is sustainable relationship between human activities and the natural world, which does not diminish the prospects for future generations to enjoy quality of life at least as good as our own. So I wish the efforts and the endeavors of chemistry and physics department in conducting national webinar to be memorable success, and at the same time I express my deep confidence that all participants will immensely benefited by the knowledge shared by the uh, distinguished resource person, Professor Lokesh, so Vijayanagara Sri Krishna Devaraya University, Ballari. Once again, I wish you all. Thank you very much.
Thank you very much, sir, for your inspiring address. Now, I request Srimati Shambhavi, HOD of Chemistry, to introduce our esteemed resource person, Professor K.S. Lokesh, who has wholeheartedly agreed to carry out the session of this national webinar.
Good morning to all. Indeed, it is a monumental pleasure on my part to introduce today's resource person, Dr. K.S. Lokesh, to all the participants of this national webinar. Dr. K.S. Lokesh was born in year 1976, completed his post-graduation in chemistry, bagging the first rank from University of Mysore in the year 1999. From the same university, he attained a doctoral degree in chemistry in the year 2005. Started his professional career as a chemist in Sipla, Bangalore, then served as an assistant professor of chemistry, Shinshu University, Japan, till 2012. Probably with the intention to serve the motherland, he returned to India and got appointed as an associate professor of chemistry in VSKU Ballari in the year 2012, and ultimately got elevated as a professor of chemistry in the year 2015 and has been serving till date. All through his career, he has been awarded multiple prizes for his papers and impressive lectures in seminars, conferences, and scientific meets held over and across the world. From the year 2003 to till date, in all his 76 papers and articles have been published, and among them 70 papers have been published in international journals. In addition to the paper publication, he has authored many books and contributed chapters on enzyme-based sensors and biosensors and electrochemical nanosensor application, which got published in Netherlands and elsewhere in 2020. Under his efficient guidance, 7 students have been awarded PhD degree, and presently he is guiding 6 students. Professor K.S. Lokesh holds number of offices and responsibilities in the university. These are just but a few of his achievements as a professor of chemistry. In fact, our college and our Department of Chemistry and Physics is feeling blessed to have this determined and dynamic personality as resource person for today's webinar. Thank you.
Thank you very much, ma'am, for introducing Professor K.S. Lokesh to the participants. Now there is an announcement. The participants who wish to ask the question should share their questions in their chat box, and feedback link will be sent in the chat box. Now I request Professor K.S. Lokesh to share his profound knowledge on today's topic.
Good morning, everyone. Am I audible? ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
Yes, sir. It's audible.
Okay.
ಕೇಳಿಸ್ತಾ ಇದೆ,
Fine.
sir. It's audible.
Thank you. So, first of all, I thank the Governing Council of ASM College, Principal of ASM College, Professor Timmareddy sir, and the Chairman of Chemistry Department and Physics Department for inviting me to deliver this lecture. It's my pleasure to have accepted this invitation, and I thank everyone for this invitation. So, and also I thank Professor Shambhavi Madam for introducing me in a brief introduction. Thank you, Madam. So, Today I am going to deliver the lecture on the development. So what is sustainable development? As Professor Principal told already, sustainable development is very important, where we need to have the development so it can reach each and every person at the society. So even the person in the remote area, even the last person in the society needs to have the facilities or comforts from science. But we need to have a control on it so that it should not destroy the environment or the resources for our future generation. So the development should be in such a way that it should not affect either the resources or the environment. So we have to have some control in destroying the environment, but the development should be able to reach each and every person in the society, So in this regard, we have taken this seminar on nanotechnology for sustainable development. So what are the promises that nanotechnology gives us? What are the promises of nanotechnology? It says, or it promises, that with the help of nanotechnology, we can defeat poverty. We can overcome the starvation and diseases. We can have most of the remedies with nanotechnology for curing the diseases. It opens up, nanotechnology opens up the outer surface. It may be space or other surface where we can utilize the resources from other spaces for the development of humankind. And it also expands human capacities, and it increases the lifespan of humans. So based on these promises, the researchers and scientists are working to put into force. So in my talk, I will be talking about nanoscience and the applications, which we call it as nanotechnology, and a few slides related to the research work which we are carrying out in our department. So I will go through the basics of nanoscience and nanotechnology, then few applications which have been implemented by nanotechnology, and then what we are doing in our department at the university. So what is nanoscience, or what is a nanomaterial, or what is nano? So when we talk about nano, it's nothing but we say 10 to the power of minus 9 meters. 10 to the power of minus 9 meter, or 1 part of billion. 1 part of billion. So when we say 1 part of billion, we may not have proper idea what is 1 part of billion. Then if you take the width of a hair, you may be knowing this is the figure which shows is one of the very eminent scientists and Nobel laureate, Einstein. So if you take the hair of any human being, and if we cut into the hair, width of the hair or thickness of the hair into almost 1 lakh times, then the small part we get is considered as 1 nanometer. So I repeat, if you take the hair, human hair, and if you take the thickness which may be of 0.1 nanometer, 0.1 millimeter to 0.2 millimeters, and if you cut the thickness or width of the hair into around 1 lakh times, then each part of the hair which has been produced is in the size of 1 nanometer. 1 nanometer. That means it is very difficult to imagine the nanometer scale. So such a small part it is. So if you take various molecules that are existing in nature, from water to bigger molecules, water, it is having 0.1 nanometer. If you take a water molecule, a single molecule of water, it is having that size of 0.1 nanometer. Then if you take a bigger molecule, slightly bigger the molecule than water, that is glucose molecule. One glucose molecule, if you take, it has a dimension of 1 nanometer. It has a dimension of 1 nanometer. Then if we go to antibodies, then antibodies are still having higher size, and they have a size of around 10 nanometers. Right now we are speaking about virus. So whether it is coronavirus, so the viruses in general have a dimension or size of 100 nanometers. So if you take a tennis ball, if you take a tennis ball, this tennis ball is very bigger when you compare to nanometer scale. So the tennis ball is around 10 crores nanometer, 10 crores nanometer or more than that. So that much big is tennis ball where compared to water molecule. So the water molecule which contains H2O, it is having a size of 0.1 nanometer, that is 1 Armstrong, around 1 Armstrong units. Whereas if you take a glucose molecule, a single glucose molecule, it is having a 1 nanometer. So as the size increases, you can see the nanometer level also increases, scale of the nanometer also increases, and you have various sizes. So why people are so much interested in nanotechnology? What it makes nanotechnology so important? So the materials at nanoscale have different chemical, physical, as well as biological properties. The properties of the materials varies at nanoscale compared to bulk scale or atomic scale. So that is why people have very much fascinated about the variation in the properties of the materials at nanoscale. So nanotechnology research and development is directed towards understanding, creating the improved materials and systems that exploits the special properties of nanomaterials with respect to physical properties, chemical properties, and biological properties. So the nanotechnology exploits the properties of the nanomaterials to prepare what we call very special materials for different applications. How surface area scales changes. So when we talk about nanomaterials, the important two properties which influences properties of the nanomaterials
Hello.
prepare what we call
Sir, mute ಆಗಿದೆ ನಿಮ್ದು.
materials for different applications. How surface area scales changes. So when we talk about nanomaterials, the important properties.
ಸರ್ ನಿಮ್ದು ಮ್ಯೂಟ್ ಇದೆ ಸರ್, ಇನ್ನೊಂದ್ ಕಡೆ ಅದು ಬೇರೆ ಇನ್ನೊಂದು ಯಾರೋ ಜಾಯಿನ್. ಈಗ ಥ್ಯಾಂಕ್ ಯು ಸರ್. ರೈಟ್,
ಎಕೋಯಿಂಗ್ ಆಗ್ತಾ ಇತ್ತು ಸ್ವಲ್ಪ. ಓಕೆ, ಸೊ the two properties which influences the various properties of nanomaterials are, one is surface area and the other one is surface energy. Surface area and the other one is surface energy. If you take a single particle of any material which is having a radius of 1 centimeter, then if you cut into 8 particles with the radius of 0.5 centimeter, 0.5 centimeter, then the total volume remains the same. The total volume remains the same, but after crushing or splitting a particle of 1 centimeter into 8 particles of 0.5 centimeter, then the surface area increases thousands of times. The surface area of the material increases thousands of times. This enhancement in the surface area is responsible for change in the physical properties, chemical properties, and biological properties of nanomaterials. So due to the enhancement in the surface area of the nanomaterials, there is a change in the chemical, physical, and biological properties of the nanomaterials compared to bulk materials or bigger materials. So what happens with change in size?
Dear participants, a small technical issues. So sir will back soon. Sir, you are back. You can. ಕೇಳ್ತಾರಲ್ಲ
Dear students, dear participants, there is a small announcement. There is a network issue. Please wait for 2 seconds. Resource person will be back soon.
Yes, dear participant, sorry for the inconvenience.
Hello, ಕೇಳಿಸ್ತಾ
So
ಇದೆಯಾ?
now the first person. Yes, sir, ಕೇಳಿಸ್ತಾ ಇದೆ. The first
Okay,
person
okay.
back. So
Sorry.
again,
Yeah, probably there is some wind over here. Probably that's the reason, or network problem, it seems. I'm sorry for that.
yes, sir. Yes, sir.
Okay. So what happens to the nanoparticles with size? So as the size decreases, the color of the nanoparticle also varies. The strange things happen at the small scale. If you keep cutting until the gold pieces are in the nanoscale range, they don't look yellow in color anymore. They look red, blue, or orange color with variation in the size. So depending on size, they can have different colors. So why there is a different colors for different sizes? So the difference in thickness results in difference or variation in reflection and absorption of light by different sized gold nanoparticles. Nanometer looks arranged in color, So,
ಕೇಳಿಸ್ತಾ ಇದೆ.
okay, then we'll go for the properties of different sized particles, different sized gold nanoparticles. So if you take a gold nanoparticle of 1 nanometer, it is having a melting point of 700 degrees Celsius. It melts at 700 degrees Celsius, and it shows a peak in the absorption spectrum, that is UV visible absorption spectrum, at 420 nanometer, because it is yellowish orange in color or brownish yellow in color. Whereas if you take a nanoparticle of 20 nanometers and it shows a melting point of 1000 degrees Celsius, 1000 degree Celsius, absorption in the UV visible spectrum is 520 nanometer, because it is red in color. The nanoparticle of gold, which is having a size of 20 nanometers, is red in color. Whereas a gold nanoparticle of 100 nanometer, it shows a melting point of 1000 degrees Celsius, and the wavelength of absorption in the UV visible spectrum is at 575 nanometers, and its color is purple pink. But if you take a bulk gold material or a big gold material, then it is having a melting point of 1064 degrees Celsius, and its color is golden yellow. So the same gold, if it is cut into smaller particles in nanometer level, it will not be any more golden yellow, and it changes its color from brownish yellow to red to blue or purple pink. So this change in properties is due to, or optical properties is due to, variation in the thickness of the particles, which will influence the reflection and absorption of the properties of the material. So you will have changes in properties of the nanoparticles due to change in size. So how nanoparticles are prepared? The nanoparticles can be fabricated or designed based on two methods. One is top-down approach. The second one is bottom-up approach. In case of top-down approach or top-down synthesis of nanoparticles, we are going to start with large materials. We are going to start with large materials, and the large materials are brought into smaller particles into the nanoscale. So bigger materials are splitted or crushed or divided into smaller particles in case of top down approach. Means top means bigger particles, down means smaller particles. From bigger particles to smaller particles are formed. That is called as top down approach or top down nanofabrication. So the top down method is used in the preparation of computer chips and for various electronic applications. The methods employed for in case of top down approach or top down nanofabrication is laser ablation method and chemical vapor deposition techniques. Chemical vapor deposition techniques. So you can see on the right side, you have bigger material. From the bigger material through laser ablation or through by chemical vapor deposition, we have or the scientists have designed nanomaterials of the scale in the scale 1 to 100 nanometer, 1 to 100 nanometer. So the left side, maybe it's not clearly visible, it shows the Moore's law. The Moore's law. What Moore's law says, according to Moore's law, the size of the transistor, it was given in the year 1959 by scientist Moore. So he says that the size of the transistor decreases. The size of the transistor decreases by its half every 18 months. By every 18 months, the size of the transistor decreases by one of its size. The law still holds good, though it has some limitations. So still we can see when we started having the computers in 1940s, we used to have a big computer, but we have reached a palm-like laptops or tabletops where we have lot of transistors of smaller sizes. So the size of the transistors have decreased instantaneously from bigger size to smaller size. So the second method is bottom-up approach or bottom-up nanofabrication method. So first one is top-down approach, where bigger particles are taken and crushed or divided into smaller particles. In case of bottom-up approach, we are starting with smaller particle or individual molecules or atoms, and we will build upwards to form. So we will take individual atoms or molecules. From individual atoms and molecules, we are going to have upward synthesis or bigger molecules. So bottom up approach synthesis of nanoparticles is similar to biological systems. So bottom up approach is a chemical approach of preparation of nanoparticles. So in case of bottom up approach, it is similar to biological system, and it is the chemical way of synthesis of nanoparticles. Whereas the top down approach is a physical process of preparation of nanoparticles, where you are splitting the bigger molecule using laser radiation or by crushing. So for bottom up approach, we have an example of molecular self-assembly through hydrogen bonds. Molecular self-assembly through hydrogen bonds in case of water molecules or other molecules. So you will have simple atoms and molecules which undergo hydrogen bonding to give a self-assembly or assembled molecules, which is an example of bottom up approach, where small molecules using hydrogen bonds form bigger molecules or nanostructures. So when we say once we have synthesized the nanoparticles either by bottom up approach or top down approach, we need to see how the nanoparticle looks, or what is the size of the synthesized nanoparticle. So we need to use a microscope, but the normal microscope which we use normally for studying biological samples like optical microscope cannot be used for measuring the particle size of nanoparticles or the size of nanoparticles. So it has less resolution below 1000 nanometers optical microscopes. So in order to have a better resolution and clarity of the images of the particles, we need to use a electron microscope. So in case of electron microscope, you are going to use electrons to interact with the particles, nanoparticles. In case of optical microscope, it is the light radiation which interacts with the particles or sample. So a scanning probe microscope can also be used for imaging the nanoparticles, or to know the size of the particles. A scanning electron microscope or a atomic force microscope can be used. And right now, in addition to scanning electron microscope, we can also use transmission electron microscope, which is much more resolution, which is having much more resolution and more advanced, where you can view even the nanoparticles of size 1 nanometer. That means even at smaller scale, you can view the nanoparticles. So when we talk about nanotechnology, it consists of two segments or two sections. One is nanoscience and the other one is nanotechnology. So nanoscience is the preparation and study of the properties of the nanoparticles in the range of 1 to 100 nanometers. Whereas nanotechnology is the application of materials to develop new products or methods. That is turning the nanostructures or converting the nanostructures into usable form. That is called as nanotechnology. So in case of nanoscience, researchers learn about the chemical and physical properties of the materials which have been synthesized and having a size of 1 to 100 nanometers. They are the nanomaterials or nanostructures are the smallest things that can be made. The smallest things that can be made is nanostructures. What about nanotechnology? So the researchers develop using the nanoscience materials and properties studied. The researchers or scientists or engineers develop new products or methods that has some application, in the real world. That is called as nanotechnology. So it is like science, basic science and engineering. In the basic science, we are going to study the synthesis of materials as well as its chemical and physical properties. And in case of technology or engineering, these materials are applied for different applications. In the same way, we have nanoscience and nanotechnology. So then, what is nanotechnology? So nanotechnology is the science of manipulating atoms and molecules to make new materials and devices. So nanotechnology is nothing but manipulation, science of manipulation of atoms and molecules to make new devices and materials which have very efficient properties as well as applications. This nanotechnology is interdisciplinary in nature, where science and engineering part interconnects with each other. So nanotechnology is a interdisciplinary field where we have the interconnection between science and engineering. So in nanotechnology, we are going to study the particles of 1 to 100 nanometers, around 1 to 100 nanometers. So what are the advantages of preparing devices or materials with nanotechnology? So the nanotechnology offers lighter materials or devices, the materials with a very high strength and which are very faster and quicker, which are smaller and portable in nature. Though they are smaller, portable, they are more durable compared to the materials or devices synthesized from bulk materials. So the advantages of nanotechnology is the materials which you prepare or devices which you prepare using nanomaterials are lighter, they are stronger, they are faster in response, and they are smaller and portable. You can carry. Our lifespan of those materials is comparatively very high when compared to the devices and materials prepared from bulk materials. So most of the times we speak nanotechnology is a new field, but nanotechnology is not a new field because nanotechnology was existed even in ancient times. So nanotechnology is not new. So gold particles in glass are normally shows or reflects red color. If you add gold nanoparticles in glass, they show reflection as red. So ancient time glassmakers, ancient time glassmakers knew that if they add finely ground gold and silver nanoparticles, they would get beautiful colors of different colors they used to get if they add the nanoparticles of gold and silver to glass. They used nano-sized gold and silver
Excuse me,
nanoparticles.
sir.
Yeah.
Here someone are
Yeah,
making
put
some
some
things.
marks.
Sir, MC Mali Patil, SG Mali Patil, sir, and even Chidananda something. They are doing something. Scratching on the screen, sir. Please stop the share and again you can share this one. Sir,
Okay, fine.
please, we are requesting you, all the participants, should not do anything on the screen.
Okay. Is it okay now?
Yes, sir. Yes, sir.
Okay. So
Thank you.
what I was saying is nanotechnology is not a new field. Nanotechnology was known even to our ancestors, where ancient glass making industries were using the colloidal particles or gold particles of nanoparticles of gold and silver to have different colors in glass. So with these basics, we'll come to applications of nanotechnology. So with a small summarize, I want to give what are nanoparticles. Nanoparticles are materials which are having a size of 1 to 100 nanometers. And the nanoparticles are important because they have high surface area as well as high surface energy, and their chemical, physical and optical as well as biological properties varies with size. So in order to exploit these properties, we have nanotechnology. So the nanotechnology, which is a field of, which is a science where we manipulate the atoms and molecules to get very highly efficient devices and materials. So the applications of, now what are the applications of nanotechnology? So the applications of nanotechnology spans in many areas. So you can say almost all the areas are domains. So you can use that nanotechnology or materials from nanoscience in advanced materials and textiles. You can also use in energy and environment, in aerospace, medicine for health, food and agriculture, national security and defense, transportation, biotechnology, mechanical engineering and robotics, and information technology. That means in most of the application, in most of the dimensions or domains, you can find the applications of nanotechnology. So nanotechnology finds application in almost all areas. So we'll go by one. So material applications of nanotechnology. So using nanotechnology or nanoscience materials or nanomaterials, we can prepare fibers that are stronger than spider web. So we can prepare fibers which are much stronger than even spider web, and we can have metals stronger than steel using nanoscience and nanotechnology. So we can have or synthesize metals which are 100 times stronger than steel and which have weight of less than 1/6 of the respective metal. You can have catalysts that respond more quickly and to more agents. You can prepare plastics that are capable of conducting electricity using nanoparticles and nanotechnology. You can also prepare coatings that are nearly frictionless. Especially this is highly useful in shipping industry. You can prepare the nanoparticles which can change color and transparency on a specific demand, or the nanoparticles or nanotechnology can be used to prepare materials which change color and the transparency based on its requirement or demand. You can prepare materials that are self-cleaning, self-repairing, and never needs repainting. So using nanotechnology, one can synthesize materials which are self-cleaning, self-repairing, and never needs any type of repainting. So the nanoscale powders are 5 times as light as plastic materials. So you can prepare nanoscale powders which are as light as, or which are much lesser weight than even plastic materials, but have the same radiation protection as like metals. So that can nanopowders which have lesser weight, but they have higher strength to protect from radiation, So then we can also use nanotechnology in energy applications. So one of the applications of nanotechnology in energy field is in fuel cell and batteries. Fuel cells, batteries, or solar cells, or even in supercapacitors. So if you use nano catalysts in fuel cells to convert the energy from fuel. Then the efficiency increases. The efficiency of the energy that is given out increases. Batteries have the capabilities to store more energy and are more durable when we use nanotechnology and nanomaterials. And plastics and paints will store the solar energy and they convert the solar power into solar energy. So you can prepare nanotechnology based plastics and paints that can capable of storing solar power and can convert solar light energy into electrical energy. Then we can also use the nanotechnology in computing applications. So silicon is hitting the size limit. As I said, as per Moore's law, the size of the transistor decreases by 1/2 every 18 months. So it is according to Moore's law. Now it has reached almost maximum limit. In order to decrease the size of the transistors, we need to replace the silicon with super chips. We need to replace the transistors which are made up of silicon with the super chips, which are the combination of silicon and gallium arsenide. So using these super chips, one can prepare wireless chips. And the plastic semiconductors manufactured by printing devices will become very cheaper. And you can have electronic papers or electronic billboards in for advertisement and publicity, which is very cheaper using nanotechnology, So what are the nanoscale products which are already in the market? So some of the materials are devices which are already in the market are based on nanotechnology, which are in the market are silver nanoparticles. They are used for antibacterial wound dressing. So these silver nanoparticles are antibacterial and they have been used for antibacterial wound dressing. And another material which is already in market is engineered calcium phosphate. This is a duplication of microstructure and it has composition and performance as like human bone. Calcium phosphate has the composition and performance as like human bone. And also nanotechnology is used to prepare nanoparticles for dental restoration. And the cosmetics have been prepared using nanoparticles which are called as nanosomes. So these nanoparticle based cosmetics do not penetrate inside the skin. When they do not penetrate inside the skin, the side effects are less. Then even the sunscreens which are used are made up of titanium oxide and zinc oxide nanoparticles. So these are some of the applications of nanoparticles or nanotechnology which is already in the market. So for example, sunblocks are sunscreens which are used to protect from UV light or sunlight. So they are made up of zinc oxide and titanium oxide nanoparticles. So both these nanoparticles are employed as opaque sunblocks. When these particles are in nanoscale, these white patches on this player maybe mycology, is not visible to the others. They become invisible to the human eye, but they still have the capability to reflect the UV light radiation from the sun. When you are outside and when you have high sunlight, then you can use the sunblocks of nanoparticles, that is zinc oxide and titanium oxide, to reflect the UV light radiation. So the modern sunblocks can provide a physical barrier without the classical appearance which is seen on other type of sunblocks or sunscreens. Another application of nanoparticles and nanotechnology is in the preparation of antimicrobial fabrics. A company called Nano Horizons, which is situated in Venezuela in USA, they have started preparing silver nanoparticles, which can be used both as dye and in polyesters and nylons. These silver nanoparticles, when they are applied in preparation of the polyester and polynylon based clothes, they are toxic to microbes. And the colonies of microbes will not form. And clothes using this material will not have any type of bad smell or odors. So the clothes are the materials that are prepared using silver nanoparticles do not allow the colonies of microbes to form, and you will not have the bad smell that comes from the silver nanoparticle based clothings. So you can use the nanotechnology or nanoscience in the preparation of stain resistant clothes. So the nanofibers which are created using nanoparticles, they have a cushion of air around the fabric. They will have a cushion of air around the fabric, and they will resist any type of liquid stains on the cloth. So here you can see a 10 nanometer carbon whiskers that bonds with cotton. Then it will not have, or it will not allow to have any type of stains on the cloth, and the liquids on top of this type of clothes just rolls off from the surface of cloth. So you can see here in the left side of the image, the nano pants that refuses to liquid stain. So if you add liquid on the surface of the nano pants, then it will not stick to the pant, but it will get roll off, or it will wipe off from the surface. So you can see the various liquids that have been put on the nanoscience based or nanoparticle based clothing, and they do not have any stainings when it was wiped off. That means the clothes prepared using nanotechnology, they are stain resistant in nature. So the nanotechnology can also be used in the protection of the environment. So here you can prepare the nanoparticle based or nanotechnology based paints which have the ability to clean the air. So if you coat the nano paints on buildings, they react with the pollutants and they decompose the pollutants into a non-hazardous material, and which can be washed off with rain. So these nano paints which are made from nanoparticles, they have the ability to decompose the pollutants present in the atmosphere. When exposed to light radiation, the nanoparticles present in the paints, that is titanium oxide nanoparticles, breaks the organic and inorganic pollutants, and those decomposed or broken pollutants are washed off during the rain. So these nanopaints, which are made of nanoparticles, they can decompose air pollution particles like formaldehyde. So you can use the paints as the purifiers of environment based on nanotechnology or nanopaints. So you can have the nano solar cells also, In case of nano solar cells, they are mixed in plastic and could be painted on buses, roofs, and clothing. So nano solar cells mixed in plastic and could be painted on buses, roofs, and clothing. So then when you start converting solar power into light energy, then solar energy becomes a cheap alternative energy. So here you can see a inorganic nanorods embedded in semiconducting polymer has been loaded on a bus, which absorbs the solar radiation, and it converts the solar light energy into electrical energy. So the nanotechnology has a bigger role or application in memory storage devices. So using nanotechnology, one can prepare a memory stick which can store data up to million movies. A memory stick itself can store data up to million movies in single memory stick. So the current CD and DVD media have storage scale in micrometers. So the storage scale is in micrometers in the present CDs and DVDs, which we use for storing the either movies or data or audios. So the new nanomedia, if you prepare the DVDs or CDs using nanomaterials, that is new nanomedia made when gold self-assemblies into strips on silicon. They are made by gold self-assembles. When gold self-assembles on silicon, you get nanomedia. So they have the storage scales in nanometers. That is 1,000 times more storage along each dimension of the material. So they are capable of the nanomedia, or the devices for storing based on nanomedia are capable of storing 10 lakh times greater storage capacity or data compared to the existing CDs and DVDs. So when you have the storage media in terms of nanometer scale, then the material is capable of storing 10,000 times more storage data than the existing CDs and DVDs. Then the future directions, what else can be done in case of energy? So you can have solar panels. These newer solar panels can be incorporated in nanocrystalline silicon. So these are new type of solar panels that can be incorporated in nanocrystalline silicon. So these newly developed solar panels increases the efficiency of absorption of light, and when you have increased absorption of energy, light radiation, then you have better conversion efficiency and better electrical energy from solar energy. So the upcoming solar cells incorporate the proposed solar cells incorporate or consist of nanostructures based on rods, ribbons, or particles of different nanoparticles to increase the efficiency of conversion of light radiation into electrical energy. So you can also prepare nanophotonic sensors which have the ability to sense various toxic materials in the working area, in the working place. So mines and other enclosed environments could use fiber optic sensors to detect the various harmful pollutants. An ultra thin layer of metal allow specific pollutants or a specific pollutant to adhere on top of the surface, but light could still pass through and detect them. So this allows real-time analysis of the pollutant in the working place or in the confined zones. So you can also use the nanoparticles or nanotechnology in the area of biosensors. If you want to determine any proteins, then the proteins can be determined using nanoparticles or nanotechnology. Antibodies can be anchored to nanoparticle surfaces to collect specific proteins. Is inside on top of the nanoparticle, various antibodies have been attached. So here MMP antibody has been attached. This is matrix metalloproteinase antibody has been attached on top of the nanoparticle. So when these antibodies are attached on the nanoparticle, then they have more surface reactivity and they bind with the proteins. So once you have the interaction between the antibodies and proteins, then the nanoparticles can be removed. So here in this example, the nanoparticle which is used to attach the antibodies onto the surface is a magnetic in nature. Then after interaction of the antibodies with the proteins, you can remove the nanoparticles by analyzing it in the magnetic field. So there are a lot of applications of nanoparticles in medicinal field. The currently nanoparticle finds applications in drug discovery and drug delivery. In the future, the goal is to make the nanoparticles multifunctional. That means single type of particle or nanoparticle will have diverse applications and can be controllable by external signals and local environment of the cell or tissues. So in future, the scientists' goal is to make nanoparticles of multifunctional nature and which can be controlled by external signals or local environments. So the different applications of nanoscience and nanotechnology in biomedical applications are cosmetics, in the preparation of cosmetics, that cannot penetrate the skin, to find the cure for AIDS, cancer, Alzheimer, and diabetes, which are very important in these days. And the nanotechnology is also helpful in the its ability to use cells in vivo. And nanomaterials can be used to clear the flakes inside the tissues or vessels. The flakes formed inside the vessels can be cleared using nanomaterials. The technology can be used, the nanotechnology can be used to regrow the bones and organs in human body or in animals. Nanosensors can be used to detect the diseases in human, and these nanosensors are 10 times faster and 1 lakh times more accurate than the sensors which are being employed now. Then nanofilters can be used to purify the drug or to obtain drug without any impurity or toxic material. So the nanofilters can be used to prepare the drug materials or medicines without any impurities. What are the possible opportunities for nanotechnology in drug delivery? So if you use nanoparticle based or nanotechnology based drug molecules, then they will have higher solubility, they will have better rate of dissolution of the material inside the body, they will be orally available, oral bioavailability is more, then they have specific targeting ability. If you want to target only one specific site, then this nanoparticle based material will have the property to specifically target the desired tissue or cells. Then you can use implantable microchip based drug delivery systems to deliver the drugs under controlled conditions to a specific place or a specific cell or specific tissue. So if you attach some microchip based delivery systems, then these microchip based delivery system will deliver the drug to the diseased or to the desired cell or organ, and you will have injectable delivery systems. We'll also come up with injectable delivery systems using nanotechnology or nanoscience. So one example for the treatment or application of nanotechnology in health science is the treatment of cancer. As you know, the cancer is the disease that is caused by an uncontrolled division of abnormal cells in any part of the body. So due to abnormal and uncontrolled division of cells, the cancer will cause. Whenever we come to know that cancer, then the immediate remedy for cancer or immediate cure for cancer is radiotherapy or chemotherapy. So chemotherapy is one of the diagnosing tool or one of the tool for curing cancer. So how we can detect cancer at very early stages and how we can cure the cancer using nanotechnology, that we will see. So when we use quantum dots, the quantum dots are again, they are nanometer sized particles which are having the structure properties as like nanomaterials, and they contain free electrons and emit photons on irradiation with light. So when you use quantum dots, the quantum dots are having the properties as like nanomaterials, and when you use these nano quantum dots, then they have absorbed the UV light and they glow at a specific point. In order to detect the cancerous cells or tumor, they have used a mice. So when they inject the quantum dots into the mice, at the bottom side, you can see the quantum dots accumulate at the tumor site. The quantum dots accumulate at tumor site, and when UV light is irradiated, then you will have a glow in the UV light at the tumor site, and the healthy cells will not show any glowing of light. The presence of glowing light when quantum dots are injected to mice will give an indication that the cancerous cell presence or tumor cell presence in the body. So using the quantum dots, even 10 to 100 cancer cells present in the body can be determined, or even the cancer can be determined at very early stages using quantum dots. So even the repairs in the body can be done using nanorobotics or nanorobots. So these nanorobots or nano-sized delivery systems will break the kidney stones. They clear plaque formed in the blood vessels. They ferry or release the dead drugs at the desired cells or tissues. Whether it is cancer cells or other cells, they will release the drugs at the desired sites or the diseased sites. So how nanotechnology is used in the cancer treatment? So as you know, nanotechnology is the manipulation of matter at the atomic and molecular scale to create material with new and advanced properties. And this nanotechnology has been utilized successfully in the curing of cancer. So here they have used the gold nanoparticles as the chemotherapeutic agents, and they are being investigated as drug carriers and also photothermal agents and also contrast agents and radiosensitizers. Not only the curing, but also the gold nanoparticles have been used as drug carriers, photothermal agents and contrast agents and radiosensitizers in the curing of cancer. That means the gold nanoparticles which has been formed has a multifunctional role in the treatment of cancer. So once the nanoparticle has been introduced and it passed through the bloodstream and it reaches the tumor cell, it will bind, the gold nanoparticles binds only to the tumor cells and not to the healthy cells, healthy cells. So you can see they will make some changes in the material so that it binds only to the tumor cells and not to healthy cells. Then when you irradiate light, then you will have the curing of cancer, or the tumor cells will be removed or killed. So this is the tumor volume. What is the size of the tumor cell and what happens with the number of days on the x-axis. So if you just have gold nanoparticles injected into the tumor cell, then there is no decrease in the tumor cells. There is no decrease in the volume of tumor cells. When you have no treatment, also there is no decrease in tumor cells. But when you irradiate light radiation, just when you irradiate light radiation on tumor cells, there is, some killing of the tumor cells, but it is not completely killed. Tumor cells have not been completely killed. But when you have gold nanoparticles in the tumor area, plus when you irradiate the light radiation or UV radiation on the tumor cell containing nanoparticles, then you can see there is a decrease or killing of almost all the cancerous cells or tumor cells within 20 to 30 days. Within 20 to 30 days, all the cancer or tumor cells gets destroyed. That means using the nanotechnology, using the nanoscience or nanoparticles, you can cure the cancer. You can cure cancer. If you have just gold nanoparticles, it is not possible to cure. If you have just irradiation of the light on the tumor cells, it is not possible to kill or clear the cancer. But when you have nanoparticles which are injected into the cancerous site or tumor cells, and then irradiation will remove the completely the cancerous cells or will kill the tumor cells. So these are the different applications of nanoparticles in drug discovery and biology. That means these nanoparticles or nanotechnology based materials can be used as fluorescent biological markers, detection of proteins, probing of DNA structures, separation in MRI scannings to enhance the contrast images, in tumor destruction via heating or irradiation. In tissue engineering can also be done using nanotechnology, and in the drug and gene delivery to the affected place can be delivered using nanotechnology or nano devices. So what are the advantages of nanotechnology? So in case of medicinal field, it protects drugs from being degraded in the body before it reaches the target site. Before it reaches the target site, it protects the drugs from degradation before the drug reaches the target site or target cells. It enhances nanomaterial based drugs, enhances the absorption of drugs into tumors and into the cancerous cells. Nanotechnology allows for better control over the timing and distribution of the drugs to the tissue, making it easier for the doctors or oncologists to assess how well they work. How well they work. It prevents drugs or the medicine to interact with the healthy or normal cells, and it allows only to react with the affected cells. Thus, it reduces the side effects. So the disadvantages of nanotechnology are, so whatever the technology is developed, there will be both advantages and disadvantages. The way we use also important. So, nuclear energy can be used for producing electricity as well as for making nuclear bombs. In the same way, nanotechnology can also have a negative impact, or it can be also be used for destruction instead of development. So atomic weapons can now be more accessible and made more powerful, and when you have more powerful atomic weapons, they will destroy the universe more easily. These can also become more accessible with nanotechnology. Since these nanoparticles are very small in size, we will have the problems associated with the inhalation. It may have or causes problems as like asbestos industry, Presently, nanotechnology is very expensive, and the cost which is offered for nanomaterial or nanotechnology based materials is very high. And though it looks to be easy, it is not that easy to prepare nanoparticles with the design structure, design state, required shape, and other conditions. So various applications of nanotechnology, you can find the application of nanotechnology in various electronic items, whether it is digital cameras, TVs, laptops, or other electronic materials. You will have different applications of the nanomaterials, whether it is with respect to transistors or other areas like CD, the storage devices, where using nanomaterial, you can increase the storage capacity. You can also use the application of nanotechnology in the field of biotechnology. So you can have various nanotechnology based materials which have highly improved properties compared to normal materials. You can also find the applications of nanotechnology in the field of consumer application, whether it is paints, clothes, etc. We have better durability, better properties of these materials compared to other materials which are used for the same purpose. So the nanotechnology or nanoscience based materials will have better application, better durability compared to other materials. So then in another 10-15 minutes, what I want to do is what we are doing in our group at VSK University. So our research in VSK University is slightly close to nanotechnology, where we are using small amount of the catalyst for either sensing of the toxic materials or for obtaining the energy production, So the first topic is the sensing. With the industrialization, with the various developmental activities, various pollutants and toxic materials are released into the atmosphere. See, these toxic materials, even if they are present at low concentrations, then they have a huge impact on the health and environment. So various heavy metals or various gaseous pollutants as well as other pollutants are released into the atmosphere daily. They are enriched through food chain due to their non-degradability and non-biocompatibility. So among these toxic metal ions, mercury and chromium are important, and we also have different pollutants. So the World Health Organization has given some acceptable limits or the permissible limits. So if once it crosses the permissible limits, we will have various negative impacts or variation in the health, or even it will have negative impact on the environment. For example, if you have mercury more than 30 ppb, parts per billion, it may lead to death. It may have mental retardation. It will affect neurological system. It will have abnormal muscles. and it also causes Hunter-Russell syndrome, Fink disease, Minamata, and other types of disease, and even kidney damage. So even if the concentration of arsenic is even at 30 ppb level or parts per billion level, it has various severe effects on environment and human health. Hence, the level of mercury, whether it is in soil sample or water sample, has to be monitored. So here what we have done, we have synthesized a molecule called phthalocyanine, which is having structure similar to chlorophyll and hemoglobin. So this molecule is a redox active molecule, and we have used this redox active molecule for monitoring mercury in a given sample. Sorry, it's arsenic in a given sample. So this is the procedure which we have employed for the synthesis of this macrocycle, which is having structure of similar to that of porphyrins or chlorophyll and hemoglobin. So this material has been analyzed. Once we synthesize the material has to be analyzed thoroughly for its purity. We have made sure that the material formed is the desired material, and its molecular weight has been evaluated, and the molecular weight has been investigated using mass spectrometer, and it showed a molecular weight of 1527. That means the synthesized molecule is our desired compound, which is having the structure as like shown in the right side of the scheme, R3 in the scheme. Then we have characterized this molecule with cyclic voltammetry, which shows that the synthesized molecule is redox active in nature. And it shows two pair of redox peaks, one for the phthalocyanine macrocycle and the other one for the metal ion present in the complex, cobalt phthalocyanine complex, cobalt. Then we have on the right side of the top, we have impedance spectra, where we are studying the charge transfer resistance of the electrode, resistance of the electrode, whether how the electrode responds for the interaction between electrolyte and electrode. So the synthesized material on the electrode now has been utilized for monitoring or sensing the arsenic in the given sample. So what we have done here, the modified electrode or the synthesized material on top of our electrode, on top of a glassy carbon electrode or a other electrode, has been used to monitor the arsenic with change in concentration, As the concentration of arsenic increases, the cyclic voltammogram, or it is an instrument which is used to monitor the concentration. This instrument, which is called as cyclic voltammetry, this instrument shows increase in current response with increase in the arsenic concentration. With increase in the arsenic concentration, there is increase in the current response. So you can see, as the arsenic concentration increases, there is an increase in the current response. So in case of cyclic voltammetry, we apply the potential and record the current response. So with increase in the concentration of arsenic, there is a increase in the current response. Then a calibration curve is plotted where we have the current response for increase in the concentration versus concentration of arsenic. So you have the plot of concentration versus current response. So here you can see the CVs for 60 nanomolar of mercury at different scan rates. At different scan rates means the speed with which the potential is scanned. As the scan rate increases, the peak current, the current response also increases for the mercury present in the sample. So it indicates that there is a diffusion that is taking place between electrolyte and electrode. That diffusion is responsible for the movement of the mercury in the solution to the electrode surface. So here, this is Tafel plot, which is another tool from cyclic voltammetry, which you are going to get, which is a parameter used to describe the efficiency of current obtained with the change in potential. So, yes, a Tafel slope value of comparatively 113 milliwatt per decade was obtained. This indicates that the current response was comparatively higher at potential changes, and the over potential required is comparatively smaller. The extra energy, which is called as over potential compared to the theoretical energy, is comparatively smaller for the detection of mercury using the phthalocyanine or the prepared material on the electrode surface. So we have also obtained DPVs, differential pulse voltaggramograms, which is and again another techniques in cyclic voltammetry or cyclic voltammogram. So here, when we record differential pulse voltammograms, you can also see increase in the current response with increase in the concentration of mercury present in the sample. Mercury present in the sample. So you can determine as low as 10 to 500 nanometer mercury in a given sample. You can determine the concentration as low as 10 to 500 nanometer of mercury present in sample using this technique with the material which we have synthesized in the laboratory. So what we have done here, we have done the fabrication of a sensor. So like glucose sensor, which determines glucose, same type of sensor we have tried to fabricate, and the fabricated sensor shows a increase in current response with increase in the concentration of mercury, and this sensor is highly sensitive in the dynamic range or concentration range of 10 to 100 nanomolar of mercury, 10 to 100 nanomolar of mercury. So you can use the developed sensor for fabricating a sensor for mercury. Disconnected. For fabricating a sensor from 10 to 100 nanomolar. So these are the interference studies where the fabricated sensor shows the response only for mercury, and it will not show any response for other toxic metal ions or other ions present in the sample. It will not respond for lead, it will not respond for cadmium or zinc or potassium, but it shows response only for mercury. So using a nano assembly of the phthalocyanine on electrode surface, we were able to design a sensor which is capable of detecting as low as 10 to 100 nanomolar of mercury in a given sample. Then this is the paper we have published. Then we will go for one more application where we are working on the energy production, that is the oxygen evolution reaction and hydrogen evolution reaction. So what we are doing, we are trying to produce pure oxygen and hydrogen by splitting water. So for a fuel cell to have a fuel cell, we need oxygen as oxidant and hydrogen as fuel. It is very important to obtain pure oxygen and hydrogen for fuel cell electricity generation. So the fuel cell is a device which converts energy. Those fuel and oxidant needs to be obtained, that is called as clean energy production. Instead of fossil fuels, if you want to use fuel cell, we need energy which is fuels like hydrogen and oxygen. In order to obtain this oxygen and hydrogen for fuel cells or for other applications, whether it is in reduction process of various chemical reactions or in various steel industries, so we need to have the production of oxygen and hydrogen. So for that purpose, we have again used one molecule called again a polymeric phthalocyanine, which is again having structure similar to chlorophyll and hemoglobin. So this is the synthetic scheme for the preparation of the polymeric phthalocyanine. So we have done diazotization, then attachment of a hydroxy group via oxybridging, then we have the formation of this molecule and we get a polymeric phthalocyanine, which is a comparatively a bigger molecule. So these precursors during the preparation have been characterized with NMR spectroscopy. So NMR spectroscopy, as you know, is basically used for finding the structure of the molecules, It gives information about chemical environment of the protons. It gives information about the chemical environment of the protons. So from the chemical environment of the protons and by the number of protons, you can find the structure of the molecule. What is the structure? So based on this NMR spectra, the structure has been deduced as follows. Then this molecule polymeric phthalocyanine has been utilized to have oxygen evolution reaction for the electrochemical splitting of water to produce oxygen. So this is the cyclic voltammogram to know the redox behavior of the material, the first one, and the second one on top, the right side figure on the top shows the current densities for the oxygen evolution or electrochemical splitting of water to produce oxygen. So we have used different catalysts. When you have the synthesized catalyst along with iridium oxide, it shows the activity much better than iridium oxide. The mixture of iridium oxide plus the synthesized material showed lesser overpotential for oxygen evolution reaction and high current density. That means the composite of the synthesized material along with iridium oxide acts as a better catalyst than the costlier iridium oxide catalyst. So in the bottom right side, we can see a figure which shows the overpotential required for different electrode materials for the electrochemical splitting of water to produce oxygen. So if you use just a carbon electrode, it requires 518 over voltage of 580 nanometers. If you use just a nickel foam, then it requires 414 millivolts as a core potential for the electrochemical splitting of water to produce oxygen. If you use just our synthesized phthalocyanine, it requires a over potential of 370 nanometers. But the standard catalyst, which is used right now for the electrochemical splitting of water, that is for the production of oxygen, requires a over potential of 314 nanometers. 314 nanometers. The composite of our material phthalocyanine with iridium oxide showed much lesser over potential than the standard material or costlier iridium oxide. Hence, we can say that the composite of our synthesized phthalocyanine material or polymeric material with iridium oxide has lesser over potential than iridium oxide and better current density, and can be used to replace the standard iridium oxide for the production of oxygen during electrochemical splitting of water. Splitting of water to produce oxygen for the accident of fuel cell. So the oxygen produced here will be utilized as oxidant for fuel cell. So our composite material has shown the better activity or better ore potential as well as activity or with respect to current density compared to many of the other electrodes reported in literature. So then another one, we will talk about the hydrogen evolution reaction. Again, the hydrogen is used as fuel in fuel cell. We need pure hydrogen which can be used as fuel in fuel cells. So in fuel cell, you have oxygen as oxidant and hydrogen as fuel, and hydrogen undergoes reduction. Oxygen undergoes reduction, whereas hydrogen undergoes oxidation in the fuel cell. So you will have liberation of electrons, which gives electricity in the fuel cell. So as like oxygen, we need hydrogen also in fuel cell and also in various industries for various processes. So here what we have done, here again we have synthesized a phthalocyanine. Again, this phthalocyanine is having interior structure or core structure similar to that of chlorophyll and hemoglobin. So this material has been treated with the iron ore, which is very much famous in Ballari area, and we have obtained the magnetite ore from Sanjeev Rayan Kote in Ballari. So this magnetite ore has been milled into smaller particles of around 10 to 20 micrometers, and has been mixed with the synthesized phthalocyanine material to form a composite. Then the electrical conductivity data has been taken for the different ratio of the composites, for the different composites of different ratios. Here you can see this is only phthalocyanine. It is having lesser conductivity or higher resistance. So it is insulating in nature only when we have phthalocyanine. And when we have the mixture of the magnetite ore particle along with phthalocyanine in the ratio of 1:7.5, then it showed a better conductivity which is similar to that of metals. When we have the ratio of the ore particle to the phthalocyanine in the ratio of 1:7.5, then it shows the property of metals. So this ratio was taken for the hydrogen evolution reaction. So we have recorded the SEM images, scanning electron microscopic images. So you can see the distribution of the ore particles on top of the polymeric phthalocyanine. So you can see small in the down picture, picture, you can see this is the same image of the composite of iron ore with phthalocyanine, where the iron ore particles have uniformly distributed on top of the phthalocyanine material or polymeric phthalocyanine. So basically, the same gives an idea about the morphology or surface features. Then we have recorded the cyclic voltammogram to find the redox nature of the material or electrochemical behavior of the material. So it shows the redox peaks, that means it is electrochemically active. Then we have also analyzed the material on the electrode, material on the surface of a different material electrode. The composite was taken on the electrode surface and its charge transfer kinetics was studied. So it is highly conducting in nature. It showed better charge transfer behavior. Then the composite material on the glassy carbon electrode on the electrode surface was employed for hydrogen evolution reaction. Hydrogen evolution reaction. Normally, the platinum carbon, which is highly costlier, is used as a standard material or standard catalyst for hydrogen evolution reaction during the electrochemical splitting of water. So the costlier platinum carbon has to be replaced with less costly and easily synthesizable materials in order to commercialize the fuel cells, or in order to make the fuel cells practicable. So for that purpose, we have employed the composite of phthalocyanine with iron ore particles to for the electrochemical splitting of water to produce hydrogen. So you can see we have used various materials or various electrode materials for the electrochemical splitting of water to produce hydrogen. So in this, you can see the platinum carbon is having lowest Bohr potential, and the next green one in the left hand side plot gives the curve for the hydrogen evolution reaction during the electrochemical splitting of water on the composite electrode of phthalocyanine with the iron ore particle. That means the composite which has been synthesized in the laboratory has the ore potential similar to that of platinum carbon, which is very costly material. That means the synthesized material can be used to replace the platinum carbon to produce hydrogen from electrochemical splitting of water. So these are the ore potential that is required with the different catalysts, and the ore potential with platinum carbon is almost in the range of plus 0.03 or 0.04 volts, and with the composite it is around. Then, as I said earlier, we have used or we have determined the Tafel slope. So the Tafel slope gives an idea about the current response for change in potential, or what happens to the catalyst material with respect to over potential. So if the Tafel slope is lesser value, if the Tafel slope is having lesser value, then the material or the catalyst or the electrode substance will have lesser over potential. So you can see among all the electrode materials, the platinum carbon and the composite of phthalocyanine with ore material with ore has lesser slope value, Tafel slope values. The lesser Tafel slope value indicates that the material has a lesser over potential for the hydrogen liberation or hydrogen evolution during the electrochemical splitting of water. So we have also found the surface area of the material, and the surface area clearly indicates that the platinum carbon as well as the composite are having higher surface area compared to other catalysts. Since surface area is higher, the catalytic activity also get enhanced for the electrode materials. So this is the stability studies that have been done. So the stability of the synthesized material is very high. It do not undergo degradation. That means the material can be used continuously for production of hydrogen during the electrochemical splitting of water without undergoing any degradation. So that means the catalyst or the composite catalyst that has been prepared is highly stable in nature. So with this, I will summarize the lecture. The nanotechnology is not very new, but our ability to image it and modify it for different application has increased. Nanotechnology will modify the existing technologies and it will enable new ones. Health applications using nanotechnology drastically improve, and health concerns are also presently being investigated and studied. Cautious and well-reasoned employment of nanotechnology will improve the quality of life. And the important thing is, with the nanotechnology, where you are preparing the smallest materials which have the largest response or largest properties, will have a bigger impact on the development and sustainability for future. So this is about the lecture. Thank you very much for your patience, and if you have any doubts or clarification, please let me know.
Thank you, sir. Thank you, sir. Now
Thank
there
you.
are few questions from the participants. I
Yeah,
request
sure.
Kala madam to raise the questions which were asked by the participants.
Good afternoon, sir.
Good afternoon.
Sir, here is a question from Swati Arendra. Can we recover the nanomaterials from the patient's body that are used as drug delivery agents? If possible, then how can we do it so?
Madam, it's not audible. I'm not able to hear you, madam.
Oh, sir.
Yeah, can you repeat it once more, madam?
Okay, sir. Can we recover the nanomaterials from the patient's body that are used as drug delivery agents? If possible, then how can we do it so?
So, yeah, this is important when we are using some of the nanoparticles. So, the particles which are having a negative impact on human body, they must be recovered. Either using one of the properties, we need to recover them, whether it is magnetic or other processes, or some of the particles, nanoparticles, which are used for curing various diseases, which are injected into the body. They do not have any side effects, and they will be normally come out of the body during our daily exercise, this one. So if they are non-toxic, they will come after their fulfillment of their service, they will be ejected from the body.
Thank you, sir. So now second question is from Abid Hussain. Drugs and cosmetics, are they risky? If so, should they be used?
See, nanotechnology is still a growing field, and there is lot of research that has been taken into consideration, and we need to have a balance where we can use nanotechnology for the cure, but we need to take care also that this nanotechnology should not have any impact or side effects. So we need to balance in such a way that we have better options and the negative impacts has to be erased. So what we have to do, see, people are preparing cosmetics which using nanoparticles which do not penetrate into the skin. That means they will not have any side effects. And the drugs which are injected through drug delivery system or to cure the diseases, they normally do not have any side effects, and they only target the diseased cells or the cells which have malfunctioning. They do not affect the healthy cells. That is the advantage of nanotechnology. The drug required is very small amount because it is targeting the diseased cells. So that is the advantage of nanotechnology, where you are going to specifically target the diseased cells. But otherwise, when you take the drugs as such, the drug will be normally distributed to whole body. It will not directly interact with the disease cell, but also it may have side effect because it may interact with the healthy cells in normal cases.
Thank you, sir.
Okay.
Another question is from Kaja Moinuddin. Is the usage of nanotechnology become costly to the countries like India?
See, in the initial cases, definitely it is costlier. With the development of technology, with a lot of expertise and experience, definitely it will become cheaper. As of now, definitely it will be costlier because it is in the progress, it is in the development stage. So once it has been developed, then definitely it will become cheaper, like electronic materials, whatever we see nowadays. But there should be a lot of economy, or money that has to flow into nanotechnology or nanoscience field for the development of the technology.
Thank you, sir. Again, another question from the same person. What is the level of nanotechnology development or advancement in India?
See, nanotechnology, see, there is one property which we talk in physics, especially gyromagnetic ratio. So the gyromagnetic ratio is the one which is commercially employed for storing the data. Earlier, we had disks where we used to store only small information, small bit of information, say 254 MBs. Now, right now, we have disks or CDs which are capable of storing in 1 GB. Right, in future,
Sorry for the inconvenience. Sir, it is not audible. There is a network issue from resource person side. Please be patient. So this session will be continued in few seconds.
Hello.
Hello, sir. Now it is audible.
Yeah, madam.
Sir.
Yeah. So we have already lot of applications that are put into service or into public domain. So whether it is in the energy field or in the health sector or even in storage of devices, that is already in place right now. Even in India, we are utilizing, but no, the names have been not directly given as nanotechnology, but they are the outputs of nanotechnology.
Thank you, sir. Another question from Abid Hussain. What are the potential applications of nanotechnology in occupational safety and health? Shall I repeat
Madam,
it, sir?
occupational safety
Means industry.
yeah, understood, madam, understood. So occupational safety, especially, pardon, madam, pardon.
Occupational safety and health, sir.
Madam, actually, especially people who are working in mine or in some restricted areas, they are exposed. They are possibly exposed to various types of pollution or various types of radiations or toxic materials, etc. They need to be monitored. So in that case, these nanotechnology based sensors, where we use optical sensors of coinage metals, these sensors will sense the pollutant or radiation to an accurate level, and we can find their concentration or if the area is under control or not. That can be monitored using these nano sensors or nano based materials. And health issues, the problem is we need to take them to, for finding the health issues, we need to take them to hospital only, or where we have proper facilities to check it, and there only we have to diagnose related to the safety issues. Only thing we can monitor with respect to whether it is radiation exposure or whether it is toxic material exposure or environmental pollutants, we can monitor the exposure or the limits of the exposure. But with respect to health, we need to take the person to the medical facility only. We cannot judge at the exposed area. Where we have facility, there we have to diagnose the issues with respect to occupational safety.
Thank you, sir. And this is the last question, sir. Cis diamine dichloroplatinum 2 complex is used in the treatment of cancer. Is nanotechnology includes this organometallic compound in the chemotherapy, or is it different, sir? This is from Neela B. Neela GB.
See, yeah. See, cisplatin is already being used for chemotherapy. Whatever the organic metallic compound that is called as commercially known as cisplatin, that is already being used for the treatment of cancer. So it is also a chemotherapeutic technique. So in case of nanotechnology, we are going to use nanoparticles, nano-based materials for curing the cancer. So you can use even organometallic compounds which are in nanoparticle size for the curing of cancer, where we irradiate the nano-based organometallic compounds with UV light, and this will kill the this will kill the tumor cells. So you can use the even organometallic compounds if we can able to prepare in nanomaterial size.
Thank you, sir. So almost all the queries are clarified by you. Thank you very much. And now over to
Thank you, madam. Thank you.
Varsha, madam.
Thank you very much, sir, for your wonderful presentation. It is a time to express our gratitude to all those who have made this event successful. I request Dr. P.J. Bindu to propose a vote of thanks.
Good afternoon to all. Thanksgiving is a sincere expression of gratitude after the success of every event. It is a great privilege on my part to propose vote of thanks for all those who have made this event remarkable success. First, I express my honest thanks to our Honorable Chairperson of the college governing body, Srimati K. Girija, for her constant support in organizing this national webinar. Thank you, ma'am. With warm respects and regards, I express my sincere thanks to our today's resource person, Professor K.S. Lokesh, who presented a thought-provoking talk. Thank you very much, sir. Now, I thank our beloved principal for his all-time support and encouragement in organizing this event. Thank you, sir. Now, I express my warm thanks to the organizing committee, Dr. Gavisiddappa Gadal, Sri Vijayendra, Mr. Gangadhar, and Mr. Khaja Moinuddin for their all-time assistance and efforts. Thank you all. Now, I thank all the participants who took an active part in this national webinar. Thank you all. Lastly, I thank all the academicians of our college, and I also thank all those who have rendered their sincere services in making this webinar a success. Thank you, one and all.
Thank you for all the participants. And now we are going to be send in the chat box feedback link form. Please fill the feedback link and I'll get the certificate.